So hello again. Welcome to the last problem for the Triple E 113 review session. And let's do an assembly code that only uses add, subtract, and or, which is the bare instructions from the ADL processor discussed earlier. And we want to create a multiplication function that translates, well, you can translate the instructions into your own machine code, then check it in binary so you can see how computers read the machine code. So here our instructions are multiply the contents of R0 and R1, then store the result to R2. So R0 is the number to be multiplied, R1 is the multiplier. And you already have hints here. We can also use the integer instructions or the add I instructions just to make our lives easier. But yeah, let's do a demonstration with Notepad. Okay. Sige. No! Hopefully you guys didn't see that. Anyways, we will reveal the answers later. So now let's say for example, we have values, some random values of A and B, right? So, right, we have R0 as the thing to multiply. And then we also have R1 as the thing to multiply with. And then R2 is where we store the result. So for this, we have to implement multiplication, but only with add and subtract. Now, right here, I'm gonna maybe give you an idea on how you can think of breaking down like a complex instruction or a complex thing such as multiplication and break it down to add and subtracts. Yeah, in this example, we're going to be using just the add and subtracts and the branches. So, let's see. How we implement multiplication. For example, let's say we have A as 5 and then B as 3. And let's say we want to multiply them. So, we know that, 5 times 3 is just the same thing as repeated addition of 5. Right? You just add 5 3 times, rather. And that gives you 15. Now, we have A, which is the thing that we want to multiply, but we want to add it instead. Because, we're breaking it down to the smaller instruction, so we want to add it 3 times. So, we already know that we have an add instruction. And we want to store that into R2. So, R2, and let's see, the thing to multiply. So let's say that's the 5. So we have R0. And this instruction tells us R0, the content of R0 and the content of R2, we will store it to R2. Now you might be wondering, in the first iteration, R2 has nothing, right? Or rather, there might be something, right, in R2 that before the instruction. So we have to clear it, which is R2, and 0. This just clears. This is just like a just in case, where it can clear out R2 in case there is, in case there is a number that we don't want to be there. Because what if like another 5 is stored there? So instead of 15, we would have 20. So yeah, we have to just clear it out. And then, and I. Because if you and this, so if this one is something and this, you and something with 0, then it clears it out right away because, anything ANDed with 0 is always 0. So that clears it out, right? Because adding, so it's AND. And let's separate this a bit because we want to have our main loop. And as mentioned earlier, repeated addition. That's why this is inside the loop. Yeah. Okay. So we have our just in case, but then we also want to have a just in case for R1, right? So we have BEQ, which is branch if equal to 0. So R1 will move it somewhere, right? Okay, now the second part of multiplication, since we already did the repeated addition, we need to have a count that helps us or helps the program, the assembly code, to stop the addition. Because if we just keep doing this, it's gonna keep repeating the addition, and it's gonna be more than 15. It's gonna be like an infinite loop. So we need a condition or something that would decrement to stop, so that we know when to stop the multiplication. And that's where 3 comes in. So right, we know that multiplication is just repeated addition, but how many times? In this case, 3 times. And that's why we can implement subtract. And I'll explain in a while why we can implement that. So we can subtract 1. And remember, R1 is the thing to multiply with. So, for example, in this 5 plus 5 plus 5 example, the first 5 is added, right? We added the first 5. Okay, I can't do bold. There. We added the first 5 here, right? And we assumed all registers are clear. So we already have 5. So in the first one, we already have 5. And then we can subtract because we already did the count, right? So 3 minus 1, that's 2. So we have 2 more 5s to add. And then in our second loop, we have a 5 plus 5, so we have 10. And then we have a 2 minus 1 because it takes the previous value because we stored it in the same register. So it takes that previous value, subtracts 1, we have 1. And because we already added these two, it's correct that we only have 1 5 left. And then in the third loop, we have 10 plus 5, which is 15. And then 1 minus 1, that's 0. So now, after that, what do we do? Because it's 0, right? We know that we can use a branch. So if right, we also need something to return to, just because after this, if we didn't add an instruction here, if we didn't add a branch here, then it would just go down, right? It would just go down to, let's say, done. But we don't want that to happen unless the value of R1 is 0. So we can have a branch instruction. So if it's not equal, where do we go? We go up. We go up back to the loop. And so we have to compare the value of R1, which is the thing that we're subtracting with, to the value of 0. And then where do we go after that? We go 2 instructions back, right? 1, 2. We want to start here again. We want to start here. And that one is -2 because we move backwards. And we're not yet done here because we still have to determine where do we branch in case R1 is already 0. Because if R1's already 0, then you're already done, right? So with that logic, we want to, with the same branch logic here, actually, we want to move 3 instructions. 1, 2, 3. After this instruction, we're done. So that mystery question mark is 3. And we can add some random instruction. Here. And yeah, that's your assembly code. Yeah, so yun. Okay, that's the last. Hopefully, I covered everything from like computer systems to complex logic. Good luck in your exam. Thank you.